Hi student, today I am going to present a case study on maximum likelihood estimations on beta binomial model. First I'll start with the description of a data that I have taken, and then I'll show you how to apply the MLE2 function, that BB MLE package, how that function can be used to get the maximum likelihood estimate in R, and then how to get the inferential aspect, such as likelihood ratio test, the information criteria like EIC, BIC, those information criteria, and measure of goodness of fit test, etc. So the data analysis, analysis of that beta binomial model based on the data that has been that would be described in the presentations, that would be fully illustrated using the MLE2 functions from, as I told, the BB MLE package, and that will help you to this particular case study would help you to analyze any kind of any model. I took beta, I am going to take the beta binomial model, but you can take any kind of statistical model to apply the maximum likelihood method to get the estimate of the parameter. So in this module I have developed a case study on beta binomial model, mainly the maximum likelihood estimations of beta binomial model. So this case study help you to understand how to get the MLE on any kind of model, though I use the beta binomial model. First I start with the description of the data, real data that I am going to use it. So the data is taken from the study conducted by microbiologist Dr. P. Whitney of Surrey University. A batch of tiny seeds is brushed onto a plate covered with a certain extract at a given dilution. The numbers of germinated and ungerminated seeds are subsequently counted. The following data show the germinated counts out of total of the seeds at different dilution. So here is I just loaded the data from the system file, the Vignet data, OROB1 RDDA, and package is BBMLE. So from the package BBMLE you can get this data is available in R itself once you load the BBMLE, and the data frame of ROB1 is like this, the dilution in and M. So that is out of M is the number of germinated counts out of N, and this is the data that you can get from this BBMLE package. We can first get the descriptive statistics of the data by summary of OROB1, and then you will get the mean, the first quartile, median, third quartile, and maximum of N and M, and the three different dilution factors are there: 1 by 1, 1 by 25, and 1 by 625, and those are 6, 5, and 5 times. As per the author Crowder 1978, a standard model is the beta binomial distribution BBD, in which the expected proportion R beta distribute is suitable for the data. Hence, we construct a negative log likelihood function that differentiates among groups. So load the library EMD book, where you will get the beta binomial distribution, the function for beta binomial distribution. So ML1 is function probe 1, probe 2, probe 3, theta and x, and then probe equals to C probe 1, probe 2, probe 3 as dot numeric x dollar dilution, and then size equals to x dollar n, and then minus sum d beta binomial x dollar m probability a probe size theta and log, because there are probe 1, probe 2, probe 3, theta and x are actually the arguments, so that can be used to get the likelihood function, log likelihood, negative log likelihood function for beta binomial distribution model, beta binomial model. So results from Crown 1978 are given here. The probe beta to probe 3 theta, standard deviation of probe 1, probe 2, probe 3, and NLL, negative log likelihood. So the full the probe difference, the full model, the homog model. And now we'll feed that by the MLE two functions, say load library BB MLE, and then BB MLE M1 equals to MLE2 ML1. Start the initial values we set as 0.5, 0.5, 0.5, and theta is 1, and data equals to x, list x equals to ORO B1, and then you get the summary, and summary giving the estimate of the coefficients probe 1, probe 2 corresponding to probe 1, probe 2, probe 3, probe, and the theta estimate, standard error, z value, and probability, and all and also the 2 log likelihood value given here. One would prefer formula interface as well. So say M1B, the MLE2, M tilde symbol, D beta binomial, probe size equals to n theta, then parameter list is probe to dilution, and start equals to list, probe equals 0.5, theta equals to 1, then data equals to ORO B1, and the summary of M1B will give you the almost the same results that you saw in the previous section. The results warns us that the optimization has not converged, excluded from summary. We also don't match the Crowder's results for theta exactly. We can fix both these problems by setting paired scale appropriately. Since we don't bound theta, that is below sigma or below sigma, we get a fair number of warnings with this and the next few fittings and profiling attempts. We will ignore these for now, since the final results reached are reasonable and match or nearly match Crowder's values. The appropriate careful thinking to do would be either to fit on a transform scale where all real valued parameter were legal, or to use the method L-BFGSB or method Bobby QA with a Optimex package to bound the parameter appropriately. You can use the surprise warnings if you are sure you don't need to know about any warnings. So here is a M2 that has been defined. So ML1 start as dot list, coefficient of beta 1, control equals to list, paired scale is coefficient of beta 1, data equals to list, x equals to ORO B1, and summary M2 that is coming like this. Calculate likelihood profile, restrict the upper limit of theta simply because of it will make the picture below a little bit nicer. So P2 equals to say profile M2, profile dot upper equals to C infinity, 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 and theta equals to 2000. Get the curvature based parameter standard deviation which Crowder used rather than putting likelihood profile. So library methods, then round standard error M2 to 3. So standard error will be provided by this probability 1, probability 2, probability 3, and theta. We are slightly off Crowder's number rounding error. So Crowder also defined a variance parameter sigma square equals to 1 by 1 plus theta. So square root 1 by 1 plus coefficient of M2 within third bracket and double quote theta will give you the standard error of theta. the variance of this theta will be given by this. Using the delta method via the delta var function in EMD book package to approximate the standard deviation of sigma. Say SQRT delta var SQRT 1 by 1 plus theta, then mean val equals to coefficient of beta 2 of theta, and then vars equals to theta, sigma equals to V curve M2 4,4, and that will give you the approximation. Another way to feed the term sigma rather than theta is to compute theta equals to 1 by sigma square minus 1 on the y in a formula. Say m to b equals to mle2 bit m, then is a formula interface. If we do, then m tilde d beta binom probability probe size equals to n, theta equals to 1 by sigma square minus 1, data equals to OR of B1, parameters are list, probability tilde dilution sigma 1, and then start equals to list, probe equals 0.5, sigma equals to 0.1. Ignore warning, we haven't bothered to bound sigma less than 1, and then round the standard error of m to b of sigma, that will give you the sigma here, and PB2, the profile of likelihood profile is m to b, and prof dot lower is c minus infinity minus infinity minus infinity at theta part 0 lower bound. And as might be expected, since the standard error sigma is large, the quadratic approximation is poor. So R1 is R bind confine P2 theta, and confine M2 method equals to quadratic and theta, and second one is the so now the row names of R1 is the spline and quadratic. So spline and quadratic methods 95% confidence interval as follows. The beta binomial plot of the profile function can be used, and plot P2 which theta plot dot conf str is true, and then plot P2b which theta, so theta it would be plotted against theta, against sigma, and plot conf str true and show the points equals to true. So points also would be displayed in the second plot. So that is the plot of profile. The homogeneous model fit. Now fit a homogeneous model, say m1 not equals to function probe theta x, and define x equals to x dollar n, and then minus sum d beta binom x dollar m probe size theta log equals to true, and then m naught mle2 m1 naught ml naught start equals to this, probe equals to 0.5, theta equals to 100, and data equals to this x equals to ORB1. The log likelihood matches with Crowder's results like this. It's easy to use the formula interface to simplify all three of the models fitted by Crowder, homogeneous, probability differing by group, probabilities, and over dispersion differing by group. So first you start with m naught 2 mle2 m tilde d beta probe size equals to n theta parameter list probe tilde 1 and theta tilde 1, and data equals to ORB1 start with this. Then similarly you update m to f, update m to m naught f parameters list probe dilution theta tilde 1, and start the list is probe 0.5 theta 78.428. m3 is again update m naught f parameter list in this, and start list probability 0.5 and theta equals to 78.424, and then you do the ANOVA, that likelihood ratio test. For likelihood ratio test you can use the ANOVA function here. So ANOVA m naught f, m2f, and m3f. The ANOVA runs likelihood ratio test on nested model and the three different model that we define, and it will give you the ANOVA and the chi-square p value, that the 2 is showing significant, that 4. And then the table for different information criteria. The various IC tab commands produce tables of information criteria optionally sorted and with model weights. Say AIC tab is M0F, F2F, F3F, and weight equals to 2, delta equals to 2, SWOT equals to 2. You will get the DAIC, degrees of freedom, and weight. And then again you can get the BIC tab for the same three models. Delta equals to 2, n observations, n row equals to ORB1, and SWOT equals to 2, weights equals to 2. So here you will get the DBIC and degrees of freedom and weight. Similarly, AIC tab that also provide you the values as DICC, degrees of freedom, and weight. I mean this is the table of information criteria that can be generated from especially from the MLE2 package from BBMLE. So that's all about the case study that I wanted to illustrate as a maximum case study on maximum likelihood estimations. I use the beta binomial model. In this case study, we have learned how to apply the maximum likelihood methods on a real data. Here I took the beta binomial model, but you can take any kind of model, and here you learn how to get the different inferential part of the statistical analysis, likelihood ratio test, the different information criteria and goodness of measure like AIC, BIC, etc. And the different informations and goodness of fit test that also we have learned here. And this case study is fully illustrated how to use the inbuilt function in R to get the maximum likelihood estimate.